Okay, so now we're going to find the area of the outer loop of r equals 1 plus 2 cosine theta. So if we graph with this, we look at a over b, so it's 1/2, so again it's less than 1, so I know that it's going to have a loop. And because it's cosine, it's going to have a loop reflected on the x-axis. My period is 2 pi. My magnitude is 2, so it's cosine, so I'm going to make a u. And because it's 1, that means I'm going to move everything up 1. Okay. So now let's look at when it's 0, I'm going to be at 3. So at 0, I'm at 3. Oops, I went a little bit too fast there. Right? At pi over 2, I'm at 1. At pi, I'm at -1, but that means that I need to go over here. So you can see what my graph is going to look like. Okay. So I want to know the outer loop. So basically what I'm looking at this whole area, the outer, not the inner. So I'm going to use this to help me find it. So if we look at my graph from 0 to this 0, or better yet, from 0 to pi over 2, okay, so if we look at from 0 to pi over 2, that is going to be, as we look at the graph here, it's going to go from here to here. That's what that represents. Okay, that's the purple section. From pi over 2 to this 0 that I need to find, that is going to be from here to 0, 0. From this 0 to pi is going to be this part of the graph. From pi to 0, so from here it's going to go to that. So if we look at this area right here, this area of the circle, represents the inner loop. Okay, that represents this inner loop. Okay. These two areas represent the outer loops. So in order to find that, I'm going to go ahead and find me the zeros. So I want when r is equal to 0, so I'm going to go ahead and set r equal to 0. Okay, so I want to find when cosine inverse is -1/2. So if I look at the unit circle, cosine is negative in 2 quadrants. We are going to be in quadrant 2 and in quadrant 3. So my first one is going to be 1, 2, 3, 4 pi over 6, or 2/3 pi. The second one is going to be, so this is 4, 5, 6, 7, 8 pi over 6, or 4 pi over 3. So those are my two angles that I need to find. And those are my zeros. So that's going to be both of these. So in order to find the area, I'm going to have to write two integrals. I'm going to be going from 0 to 2 pi over 3, and then from 4 pi over 3 to 2 pi. And that is going to give me these areas that I'm looking for. So I'm going to write from 0 to 2 pi over 3. That is this area right here, from 0 to 2 pi over 3 of 1/2 r squared, and r is given by 1 plus 2 cosine theta of d theta plus the second area. In the second area, I'm going from 4 pi over 3 to 2 pi. Okay, so I'm going to use the calculator to calculate these out. And that turns out to be 8.881. and that would be the area of the outer loop.